This lesson is on the Pythagorean Theorem. Let's check it out. Here's an example of the Pythagorean Theorem. We take A, B, and C in a right-angled triangle and build squares on them. We can cut up the square on B and take the square on A and move them in, and they become the same area as the square on C, thus proving that a squared plus b squared, which are the two shorter sides squares added together, give you the c squared, which is the hypotenuse squared. Another example of a proof that a squared plus b squared is c squared is the following. You could shear the squares, meaning cut them up into little bits and pieces and slide them down in the following manner to show that the areas of a squared and b squared give you the area on c squared. Now consider this example. You can see that the angle here is not quite a right angle. So let's see how the sides relate when we build squares on them. This side here is 5. 5 squared is 25. And this side here is 7. 7 squared is 49. 25 and 49 give us 74. So if the Pythagorean theorem worked for non-right triangles, then these two would add up to this one, which is 2, 4, 6, 8 squared, which is 64. But 74 is not the same as 64. So that actually tells us that the squares on the shorter sides don't add up to the larger side square in general, but only when the angle is a right angle in the triangle. Further, you can actually build any shape on the sides of the triangles, and the areas will remain the same. So we can state that a triangle is a right triangle if and only if the sum of the squares of the legs, a squared plus b squared, is equal to the square of the hypotenuse, c squared. A and b are the legs and c is the hypotenuse. We can use this to our advantage in calculating parts of right triangles. In solving applications that involve the Pythagorean theorem, we often want to know the following property. We want to be able to take the square root of both sides when finding the solution to an equation. So as long as our two sides are positive and equal to each other to begin with, we're allowed to take the square root of both sides. Consider x squared equals 9. What possibilities do you have for x? Well, x could be either the root of 9 or the negative root of 9, because it could be positive 3 or negative 3. However, when using the Pythagorean theorem, we're always dealing with a right triangle which has positive sides. You can't have a negative side. So we're actually going to consider just the positive principal root of 9, which would be 3. In this case, we're only considering the positive. So let's take a look at the following example. Here we have a right triangle where A is 16, B is 34, and C is unknown. So since we have a right angle triangle, we can use the property that the square of a leg plus the square of the other leg is going to equal the square of the hypotenuse. This gives us 16 squared plus 34 squared equals c squared. So 16 squared plus 34 squared is 1,412. So now if we want to counteract the squaring, we can square root both sides, and we're considering the principal root. The square root of 1,412 is 37.6 approximately. So that tells us that the length of C would need to be 37.6 units. In the next example, we have an isosceles triangle, which means these two sides are equal, with a base length of 20 inches and side lengths of 26 inches. We are asked to find the area of this triangle. To find the area of a triangle, we need the height. Since we don't have the height, we can look at what we do have. We have an isosceles triangle, and when we slice it in half, the two sides should be equal because of isosceles properties of the center tip being in the center of the bottom. So we can consider half of our isosceles triangle to be a right-angled triangle. Now we need the height, so let's call that x. We have the side length of 26 for the hypotenuse. Now what is the base here? Well, since it's an isosceles, it's been sliced in half to create a right-angled triangle, so 20 has also been sliced in half in the bottom to make 10. Now we can consider our a squared plus b squared is c squared formula. As discussed previously, we can see that if we square the x and square the 10, we should get the same as the square of 26. So that tells us that x squared plus 100 should be 26 squared, which is 676. Subtract 100 to get x squared by itself, you get 576. Use the square root property to take the principal root, giving us square root of 576, which is 24. So that tells us that the height of this isosceles triangle is 24 inches.